All right, guys. You are powerfully welcome to tonight's class. Yeah, so I hope everyone can hear me. Hope I'm audible to everyone. Yeah, so it's really great to have you guys here. Yeah, so welcome everyone. Welcome. You're powerfully welcomed. Yeah, so yesterday we had an interesting time in solving questions on random variables. We delved into discrete random variable yesterday, and we went on to talk about the expectation and variance in discrete random variable. Just to recap, you guys should be able to recollect that we said for you to say something is a discrete random variable, number one, the probability, each of the probabilities the probability mass function, each and every one of them must be greater than or equals to zero. Then the summation of every one of them must be equals to 1. These are the two conditions that must be met. All right. Yeah. Now, we also went on to talk about the expectation of a discrete random variable. And we went on to say, for you to find the expectation of a discrete random variable, you'll be going on to solve this. The summation of x times each of its respective probability mass function. So this is how you solve the expectation. And then we also talked about variance. And we said the variance will be e of x squared minus e of x all squared. All right. We then also decided to talk about some properties under expectations and variances. And I'm sure you all recollect every one of them. So without further ado, let's move quickly into continuous random variable. Quickly, if you are yet to give us a thumbs up, please give us a thumbs up quickly while we move into continuous random variable. Now, guys, just the same way you enjoyed discrete, I really believe you should enjoy your moment in continuous random variable. Now, but this is one thing I want to say. You have to be able to integrate perfectly. All right? That's very, very vital. If you are having issues with integration, then there could be some issues while solving continuous random variable. And this is why. Yeah, so let's move quickly. For continuous random variable, just like the case of discrete random variable, two conditions must be met. The first one is that f of x, of course, the probability mass function or probability distribution function. Don't forget I told you that when you're dealing with, not probability mass function, probability density function. I told you guys that when we're dealing with discrete, we use the word PMF or we say PDF, but in this case, this D will be standing for distribution function. So probability mass function or probability distribution function. When we're dealing with continuous, we say PDF. In this case, this D is standing for density. So probability density function. So now the probability density function, each and every one of them must all be greater than or equals to 0. All right, that's for continuous random variable. And also the integration of the PDF of all the limits. Of course, your x ranging from minus infinity to infinity. I hope you can understand the use of the word minus infinity to infinity. The use of that word there is just to tell you that whatever the lesser limit is, give that question, whichever question you're solving, and whatever the greater limit is. That's why we just use like a just like a dummy. So minus infinity, it's standing for, in some cases now, your limit may be from 1 to 5. So in that case, your x should be from 1 to 5. In another case, it may be from 2 to 3, maybe from 5 to 11. Whatever the limit is, you place it there. So when you integrate the PDF, taking into account the limit that was given, the integration of that, setting the limit, must be equals to 1. All right. So that's the two conditions that must be met. So I told you guys already, integration is very much present when dealing with continuous random variable. Now, don't get, of course, integration is very simple. I'm sure you guys know how to integrate already, right? That should not be an issue at all. I'm going to solve a question quickly so that, and then I would go on to expose you to many other kind of questions that could come your way. Now, this question, very simple, but should be very good for introduction. Look at the question right here. I'm sure you're already used to how questions do come under random variables. So I'm sure you know that one of the key things they always ask you to do is to find the value of a constant value, probably in this case k. So the question here is saying find the value for k for which the function would be a valid probability density function, a valid PDF. Now look at the function. This was the function that was given. F of x is equals to, now it was given as a piecewise function. We have k x squared plus 1. We have 0. Now for this function here, we have the limit of x ranging from 1 up until 4. And in this case, we have for 0 otherwise. Now you guys know how much I hate to leave any stone unturned explaining something. So let me quickly try to break some things down for you guys. The question I can really get into solving the question, but I don't want you to just focus on the solution. I want you to understand the whole thing going on here. They said find a value for k for which the function will be a valid PDF. Now, if you look at the atmosphere around that question, what they're actually saying is we have this function. It is very possible k can hold different values. If you put k as just any value, I can tell you for certain that it's very likely that, of course, not even very likely, it is certain that it's not all value for k that would make this function a PDF. Don't forget, I gave you two conditions that must be met, meaning that if any of these two conditions are not met, that would not be a continuous random variable. That means if k was something, and when you go on to integrate this function, let's say k was 2 now, and you go on to integrate the function for when k was 2 with this limit of 1 to 4. If you don't get 1 as the answer, that's not a PDF. So now, also let me talk a little bit about this limit. I may not go very deeply into this, but guys, I would explain to you why. You see this thing you have here? If you had it like this, it will still be the same thing. Let me start from there. This and this under continuous random variable will be the same thing. I will explain to you why. You would really enjoy the explanation. I just want to make sure that you are never confused. Now, let me recall something you guys understood in probably the first or second class. I told you guys that when dealing with continuous random variable, we don't take into account whole numbers. Discrete takes into account whole numbers. So if this was under discrete, this will be the values for x here under discrete will be 1, 2, 3, and 4, because we said x was from 1 to 4. And we, using the inequality, we said equals to and equals to. So 1 and 4 were included. All right. If this was under discrete, good. But under continuous, you are not taking into account whole numbers. And that's the reason why we make use of integration. Now, just calm your mind, guys. You understand that when you are starting something new, there are many things that will be coming initially strange. But later on, when you keep moving, you will see how everything will blend very well. Now, I said something that this and this will be the same thing. All this on your left hand, in some few minutes, I will explain to you why I said this. And you will really understand it, I can assure you. All right? So this range we are having here is signifying the limit that you'll be raising your integration to. This means now, oh, sorry, I still want to talk about one last thing. This one where we said zero otherwise. This is just a way of keeping your question neat. It's more like ensuring that you just balance things up. This, you don't need to pay too much attention to this second side. It's always sometimes placed in questions. So you don't need to really pay attention to this zero otherwise. This is just meaning that where your x is not 1 to 4, that means for when x was 5 upward or 1 downward, the function was 0 in all those cases. That means this is the only place where your function was this function was valid. That's the meaning of zero otherwise. All right, just understand, if you can really wrap your head around what I just said. This is telling you that the function is only defined between this range. Every other range is the function is 0. Now, let's now move on to what the question said we should do. We are told to find the value for k, for which this function, all right, will be a valid PDF. This D here is density. That means we're dealing with continuous random variable. Now, the most important thing we can use here is this second case, because for something to be a continuous random variable, we said that the integration, all right, of the function. Now, in this case, now this is the function. The function is k x squared plus 1. That's the function in this case, all right, must be equals to 1 with the limit. Now, the limit here will be from 1 to 4. So this is what you would have to solve for you to get the value for k. Following this rule that said, if something will be a valid PDF, the integral of the function with the limit that was given, in this case, your limit was 1 to 4. The integral must be equals to 1. It's on that basis we are going to now be able to solve and get for our k. Now, some of you there, you're already in your note already solving, because some of you understand integration. But for those of you that probably you're having an hard time in solving integration, I will just do a brief, of course, that's not our focus for this class, but I will just explain to you how to solve integration, but not with high intensity, because that's not the focus for tonight's class. Now, you understand that when trying to integrate, if you have x squared in your function, you know that this would, when you are integrating this with respect to x, it will turn to x. You will add 1 to the power. That's what you always do. You always add 1 to the power and divide by whatever your resultant was. So x squared, integrating x squared will be x cubed over 3. If you were trying to integrate x3, of course, that will be x. So that will solve this. Right? Now, look at Okay, can I get feedback quickly? Let me be sure that you guys are still the answer. Obviously, some guys are very good at integration. Okay, now let me go on now to integrate this. For those of you that you know how to integrate, you should have done this and gotten your answer. So to integrate this, obviously, with what I just said, this x square, integrating x square, because when you're integrating, you integrate each of the variables. So you integrate this, you integrate this. Integrating this, we'll be having x, we'll put our k outside, we'll be having x cubed over 3, all right? Now, this is plus 1. If we integrate 1, a constant, what you'll be having is 1x. You'll be adding x raised to power 1 over 1. All right? So that will be x cubed plus x. That's what we're going to be getting when we decide to integrate this function. All right? Now, of course, we are done integrating. So we'll be setting our limit 1 to 4. Don't forget, this all must be equals to 1. All right? That's the concept. Now, if you look at what is going on here, I'm sure you understand what to do next. When you have limits like this, what you want to do is to place in the values for the upper limit into the expression and then subtract when you place the value of subtract the value when you placed 1, the lower limit in. All right, look at how this is going to be like. So that means we're going to be placing 4. So we'll be having k, and then we're placing 4 now. That will be 4 cubed over 3 plus 4. This is the one we got when we placed 4. All right. I would like you put this in a bigger bracket. All right. Minus, we're going to now place 1 inside this. So you place them separately. So we have k, then we have 1 cubed over 3 plus 1. All right. So this is how we solve limits. Right. Now, you go on to solve this with whatever, probably a calculator or anything. And 4 cubed will obviously be 64. And that will be 64 over 3. So we have k 64 over 3. Then we have plus 4 minus, we have the k, then we have 1 over 3 plus 1. So this will give us what? If you do this, this will be 1 over 3 plus 1. 1 over 3 plus 1 should give you what? All right, if you solve this, this should give you 4 over 3. So this will be 4 over 3k. And this will give you what? (64). What is 64 over 3 plus 4? 76 over 3. Okay? So when you make the subtraction of this, what do you get? 74 minus 4 is what? 72. And what is 72 over 3? That will give you 24. Now, do not forget, we did not continue this, but there was an equals to 1. Don't forget, we said everything must be equals to 1. So 24k must be equals to 1. This means my k is equals to 1 over 24. All right. So this is the reason why I said for you to be able to solve continuous random variable, you have to have sound ability to integrate properly. So this is good for introduction. I would now be taking you a bit deeper. I want you guys to have real understanding of what we're dealing with. Now, let's do something very quickly. I want you guys to understand something. Under continuous random variable, there are the kind of questions you'll be seeing, and I want you guys to really understand it. Please pay attention. This was for you to just find K, all right? That was something we did when we were dealing with discrete random variable. You're always told to find a value, a constant value, and the likes. Now, there are questions that do come out when dealing with continuous random variable. And that will be for you to solve, like in this case now, they can ask you to find what is the probability of x being equals to 3. That's the kind of question that used to come out. All right. And another one could be, for instance, what's the probability of x being greater than 2, but less than or equals to 3? So this is what I want to take you guys into now, how to solve these questions. So I believe with this first solution we did, this is enough for you to understand the whole concept around those two rules and how they work. But now, the kind of questions you should expect when dealing with continuous random variables is questions around find the probability of something like this or something like this. All right. Now, I want to please pay real attention at this point because I really want to be very deep in explaining some things. When you are dealing with continuous random variable, I'm going to give you an illustration here, and I'm really hoping that this should enlighten you. Continuous random variable has more to do with curves, and that's the reason why we make use of integration. All right. Now, I want to use this curve, for instance, to explain certain things. Let's take, for instance, that we have this place at 0. Let's say we have 50. Let's say we have 100. Let's say we have 150. Please don't mind, this is just a sketch. And since I'm not trying to be exact, I'm just 0.010, 0.015. All right, just for you to understand something. So I said, while dealing with continuous random variable, you're dealing with mostly curves. And I want to give you the understanding of how you need to understand what this curve really means when you are saying something like probability of something. Now, when you get to hypothesis testing, you will be doing so much of this, which is probably one of the topics you still one of the topics you still be handling in this your program. Now, all these curves, some will talk about being symmetric and the likes. You see, when you have a function, of course, everyone here should know already that when you plot a quadratic graph, when you plot, you know what a linear graph is, you know what a quadratic graph is, and so on and so forth. This curve you have right here is the product of the plotting of a particular function. All right. Now, I'm not going to say this is it, but let's take for instance, just an instance, not being exact, that the last question we just solved, where we said our function of, now we are gotten our k to be 1 over 24. That means the function will be 1 over 24 x squared plus 1 for x being between 1 and 4. Now, this is not the case here, but I just want to give you a hang around this. It's very likely now if you plot this function, you'll be getting a curve. All right. Now, a particular function brought about this curve. I don't actually know that function. It's very possible to find it, by the way, but that's not the subject of this class. Now, after getting the curve, now they're asking you to find the probability from this function. Now, we just finished solving for the value of k. Let's say we wanted to find probability of x being equals to 3, probability of x being between 2 and 3. I want to use the curve to explain to you what that actually means. Now, number one, guys, are you still here? Please, can you indicate if you're still with me? This is very, very vital. I don't want to. Can you indicate if you can hear me? Guys, are you with me? Okay, good. Because this is very vital. I don't want anybody to miss this. All right. Now, look at something. We started by saying the integral of the function under continuous random variable for whatever limit you were given must be equals to 1. All right. Now, I'm telling you now that your function, if you decided to plot it on a graph, it will be a curve of different diagrams. This is a function produced this one now. You can have different other curves. I'm sure you guys are not very new to plotting functions. It's very easy. If you want to plot a function, this is y equals to this. Put a value for x, you get a subsequent value of y. Put different values of x, you'll be getting y. Whatever curve it produces is your curve. That's not very hard to do. Now, what I'm saying now is that the meaning of this thing we said, that the integral of the function of all the limits, depending on the limit you were given, when you do the integral of this, it must give you 1. Guys, do you know the meaning of that? The meaning of that in terms of looking at this curve is that the area under the curve must be equals to 1. Let me say that again, because that's a new thing. If this was a function, let's say this function produced this curve. Let's say this is the beginning of the curve to the end of the curve here. If you integrate this with this limit, guys, can you indicate if you're with me, please? I don't know if that's an individual thing. Some people are talking about network. Is it individual or is it general? Can you please indicate if you're with me? Okay, all right. Okay, because I was seeing some guys talking about, okay. Now, the integral of this function with this limit, we said it must be 1 if it's a continuous random variable. The meaning of that is that the area under the curve, all this area, must be equals to 1. That's the meaning. If it's a continuous random variable. The meaning of area under the curve it means that if for any instance, I'm sure you guys know what area is. You know the area of a rectangle, area of a square, area of a circle, and so on and so forth. If for any instance you were able to, of course, just using a colloquial English there. But if for any instance you was able to solve the area without needing, let's say this was possible. Let's say you could dissect this and bring a square out of it, and let's say it was possible. the total area geometrically must be equal to 1. That's the meaning of when we said the integration of the function must be equal to 1. So wrap this around your mind, that even though we say mathematically the integral of the function with its limit must be equal to 1, in diagram or using a curve, the meaning of that is that the area under the curve for that function must be, the area must be equal to 1. Now, this now brings me to solving questions like this. When you hear probabilities, this is what probabilities mean when you are giving questions like this. Now, this question cannot be solved with this one because this question is not for this, all right? But let me try and bring to you some questions that can come out from this particular graph I drew. You can be told to find the probability of x being between 50 and 150. That can be a question that come out from this particular curve. And they say, go on to find probability of your random variable being between 50 and 150. Now, what does that mean when you are looking at a curve? This is what it means. If you were able to solve this geometrically, you have to go and find the area. This is 50, this is 150. If you can find a way to find the area occupied by that boundary, that would be the answer for your probability. So if they went on to say, find probability of, let's say, probability of x being between 150 and 200. The meaning of that is that you see this place of 150, you see this place of 200. If you can find a way to find all this area geometrically, that will be your answer for this probability. All right? Now, but most times, in almost all cases, it's very difficult to find the area using your geometry because you're not dealing with shapes that fall under many of your area that you have been finding for all these many times, rectangle, circle, and all these things. These shapes are not shapes that you can easily come by the area. And that's the reason why you cannot be using geometry to solve for these probabilities. And that's what now brought us to the use of integration. So what will you have to now do if you were trying to solve this same question and you did not, or you are not able to use area? That means you were not able to go and be finding the area of this space. This is what you would have needed to have done. You would have integrated the function, whatever function produced this whole thing. You integrate the function with respect to the limit, this limit now, 150 to 200. Whatever it gives you will be your probability. That's how you solve probabilities. So obviously we're going to solve questions, but I wanted you to have the right understanding of how to solve probabilities in this aspect. All right? Now, guys, this is what I want to quickly say. Please just make sure you are still following me. Let me repeat what I just said. For you to find, let's say you are told to find the probability of x being between 100 and 200. All right? Now, ideally, if you were able to solve this area, that means you are going to be interested in the area from this spot to the area from this spot. So if you could find a way to find all this area I'm shading now, that houses 100 to 200, that would be your answer if you could. But again, it's not geometrically very possible to do that. And that's why we make use of integration, this is how you use integration to solve it. You'll be integrating, of course, the function that produced this curve. I told you already that we don't have that function. I'm just using this as an example. So whatever function produced this curve, you're integrating it with respect to this limit, that will be 100 to 200. That is how you are going to be finding the probability. So when you see these questions around probabilities, just wrap your head around this, that if you were able to find the area, let's say they give you a diagram that it was very possible to find the area. Of course, you just go on to find the area in that bandwidth, just as I showed you 100 to 200, if it was possible. But in many cases, it's not possible. In many cases, you will have to use your integration. But what you need to do is also very easy. You just need to go on to say, what's the function? Okay, I'm going to be integrating with respect to that bandwidth. Whatever the probability was, the bandwidth of the probability. All right. Now, this is now the catch. I told you guys to hang something at your left hand some minutes ago. This is where I want to really give you more light to that. I told you guys, I said, if you recollect when I told you, they gave you the values for x to be between 4 and 1 in that question we did. And I told you guys, I said that in under continuous, this and this are the same thing. And somebody here will be saying, let's pay full important. All right. This answer now, need to calculate anything to solve this question number A under continuous random variable. Understand this thing I want to say next. This question number A, the answer is 0. You don't need to calculate anything. So when you see them giving you questions like this under continuous random variable, you don't need to go on racking your head around anything. It's very simple. The answer is 0 because you are dealing with continuous random variable. Now, this is why. You'll be asking me that why did I say this and this are the same thing under continuous, not under discrete. Discrete, these are two different things. Under discrete. Because under discrete, these places will house only 2 and 3. This second will house only 2 and 3. Whereas this one will house 1, 2, 3, and 4. They are two different things under discrete. But under continuous, they are the same thing. Now, this is why. This equals to 1 that was included here and equals to 4. That means we are saying in this case, we are saying x was equals to 1 and we are saying x was equals to 4. Just like in this case, we are saying x was equals to 3 and I said the answer is 0. Why is it 0? This is why. Use the same knowledge I just gave you of area under the curve. Now, guys, I'm going to ask you a question. I want you guys to give me a very strong answer. Using area under the curve now, you can see 50 here, 100 here, 150 here, 200 here, 250 here. What is the probability of x, your random variable, being equals to 100? Using area under the curve. Don't use integration, no. Use area under the curve. What's the probability of x being equals to 100? Is anybody flowing with me? 0. Somebody says 0. Thank you. All right. Thank you. 0 is the answer. But can anybody in the comment section tell me why it's 0? Can you tell me why it's 0? Using area under the curve. The answer is very simple. When we deal with area, area is a box of space. All right. Area has to do with a box of space. You can find the area of this box. You can find the area of this box. But guys, can you find the area of a line? This right here, when we said x was equals to, it's just a line. It's not a space. It's a line. Now, it's the x equals to 100. If I wrote x was between 99.9 and x was between 100, even 100, or even 100.1 or anything. If I say 100 itself, this will not be 0 because there is already a space being created by this inequality. Because even though it may be very small, but it's significant. But when we just say x is 100, that's just a line. That's not a space. There is no space you are trying to. We talked about area. You only find area of spaces. You cannot find the area of a line. 100 will just be a line. More like if you said we are finding the area, that means you're just finding the area of this place. It's not possible. So you needed to have like even though it's from here to this place, even though it's very small, that at least is an area. So there has to be at least a space. If it's on 150 to 151, it's still a space. But just say the area of 150, it doesn't exist. It's zero. The probability of that is zero because you can't find the area of that space. That's the reason why I said these two things are the same thing, because one, this case and this case, there is no difference because the equals to 1 doesn't add anything to these two things. So if you were given this the value for x ranging between, if you are given this range for x, you will be using your limit as your integral limit as 1 to 4. If you're given the second one also, you will still be using your integral limit as 1 to 4. All right. So that's very, very vital for you guys to note. So that when you're dealing with discrete, of course, it's a different ball game. But when you're dealing with continuous, understand that you are dealing with these things equals to a particular number is always going to be 0. So that's this and this, there is no addition, this doesn't differ from each other. So guys, have I been able to communicate something to you people? Have I been able to communicate? Are you guys flowing with what's going on here? So let's do a little oral test. You guys will be flinging your answers here. Can I get your feedback? Have I been able to communicate the last thing I just said? Were you guys able to understand very well? Okay, that's good. I like that. Okay. 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 Good. 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 Okay. Okay. All right. So you're going to be answering these questions very you're going to answer these questions. Let me see how you guys are able to fare with it. Okay, so we have 4 here. This actually went through 3. Went through 3 and stopped here. So this is actually stopping at this point. Okay. So now, of course, you should recognize that this 1, 2, 3, 4 represents the x value, and this obviously represents the PDF. So guys, this graph we have right here, could this be the graph of a probability density function? Could this be the graph of a PDF? Let me get responses. Okay. Somebody said no. Somebody said yes. Okay. Please, can you back up your answer? If it's yes, what's your answer? If it's what's your reason why this is a PDF? If it's no, what's your reason why it's not a PDF? Okay. Visual Priest said no. Okay. William said yes. Omojola said yes. Can you back up your answer? The answer given by Priest is actually not the case. Somebody said Priest said PDFs are not usually curved. PDFs are not usually curved. That's not going to be the reason why it's not a PDF or it's a PDF. PDF could be a straight line graph. All right. You don't have to restrict PDF to just curves. All right. So if you're saying no, let it be for a different reason, not the type of graph. Okay, so I'm trying to get your response. Is anybody there with a very solid reason why this is a PDF? Probability density function. Is somebody saying you can't hear me? Is that general or just you? Okay. Are you guys okay? Can you guys is it a general thing? Some people are saying network. Please. Okay, it's just him. Okay, all right. So you guys are clear. You are okay. You can hear me well. Okay. So I think I saw somebody that said something very impressive. Let me try and check the comment. Somebody said something that I feel is the answer. Okay. Somebody said it takes negative value which are not allowed, so it's not. That's the perfect response. All right, guys. The reason why this is not a PDF, the reason why this is not a PDF is because of this. All right. It's because of this. Look at, in all these cases now, we said, of course, when x was 0, y was the PDF, when the PDF was 0.6, this and so on and so forth. When x was 2, it was something. When x was 3, it was 0. No issues in all these cases except this. When x was 4, what's the PDF? Minus 0.2. And we said something. we said something. We said PDFs, all the function, let me use the function, it's better written this way, must be greater than or equal to 0, every one of them. In all these cases, they were all greater here. But in this one, when x was 4, it was minus 0.2. When x was 4, it's more like when x was 4, your PDF was minus 0.2. This is not permitted. It has negated the first rule, which must be fulfilled. We don't need to examine any other thing. Of course, if it all fulfilled this rule, if this rule is fulfilled, you must also still go on to examine the integral of f of x being equals to 1, or the area under the curve being equals to 1. So these two rules must be fulfilled before you call something a PDF. So that's good. I'm sure that's well understood. I don't want to leave any stone unturned. You could be asked questions like this, where they're showing you a diagram and they're asking you if this is a PDF or not. Now, let's see this diagram also. You guys will have to recognize if this is a PDF or not. If it's a PDF or not, you'll be telling me. Now we have 0.3 here and we have 4 here. So, guys, could this be a PDF? All right. Could this be a PDF? When I'm saying PDF here now, I'm saying probability density function under continuous random variable. All right. Could this be a PDF? Okay, Adebayo said yes. Reggie Odoyo said yes. Yeah, he said yeah. Precious said yes, sir. Okay. Okay, let me get options. Everybody are saying yes. Okay. So can you back up your answer why this is a PDF? Can you back up your answer? Everybody are saying yes. Now, guys, you none of you got it. And I'm going to show to you why you didn't get it. And I'm not going to prove it without doing two things. Before you decide something not being a PDF or not, I told you two rules must be fulfilled. Number one, all the probability density function must be greater than or equals to 0. Number two, the integral must be equals to 1. Or another way of saying this, which I explained already, is that the area under the curve must be equals to 1. Now, since there is no way this first one, let's see if it's fulfilled. If you look at this graph, everything under this graph, because this is your x value, we didn't have to write x being 1, 2, 3, 4. But you can see this graph, the way it's outlined. If this was even 1, let's say this was 1, 2, 3, 4. Let's assume this is 1, 2, 3, 4. When x was 1, the PDF will be 0 point something. When x was 2, of course 0 point something. When x was 3, of course 0 point something. When x was 4, of course 0. So you can see that this first rule is perfect. This first rule is perfect. All the probability density functions are all greater than or equal to 0. No one is, you didn't have anything that proceeds down that is having to be, for an x value that is having to be negative. I'm sure you guys understand that. So the first one is perfect. All right. That means the first rule is fulfilled. But let's check the second rule. Now, it's not very possible to be checking the integral of the function because we don't even know the function that produced this. So the way we can use to get these other things by using this other scenario where we are going to be saying the area under the curve. So guys, what's the area under this curve? What shape is this? This is a triangle. Half base times height. What's the base here? The base here is 4. That's half times 4. What's the height? The height is 0.3. Calculate this. You have 2 go here 1. You have 2 go here 2. That's 2 times 0.3. This gives you 0.6. This doesn't give me 1. The area doesn't give me 1. So obviously, this is not a PDF. The area under the curve must be equals to 1. If it's not equals to 1, then it's not a PDF. All right. So that's good. I'm sure you guys are learning something good. So let's see this other shape and let's see what you say about it. So this 4 proceeded to this point here, 0.4, and this line went from here. Yeah. All right. Is this a PDF? Is this a PDF? A probability density function? Is this a probability density function? Is this a probability density function? Okay, people are saying yes, this is a PDF. Be very sure of your answer. Can you prove to me why it's a PDF? Those of you saying it's a PDF. Why will you call this a PDF? Are you very sure this is a PDF? All right, now let's try and examine this. The first rule says all the probability density functions must be greater than 0. When x was 1, see that all the values of x, none of them went to the negative side. So the first rule is fulfilled because x was 1, maybe this is, if you try to trace it up, when x was 1, this would be like maybe 0 point something, when x was 2, and every other x value, because don't forget, this is not discrete where you must have integers as your x value. Every value of the x's, they are all going to give you the PDFs that are positive. So that set value of the area is this. This is a trapezium, right? And this is half a plus bh, right? You know, I told you guys when I was explaining, I said if it was possible for you to solve the area, you don't have to go and be integrating. So in this case, you can solve the area. This is possible. So half a plus bh. Your a here is, if you understand how to solve the area of a trapezium, this is your a. This will be your b. More like if you held the trapezium, like this is your a, this is your b, this is your height. Your height is 4. So this is half 0.1 plus 0.4 times h, which will be 4. That will be half 0.5 times 4. All right. 2 will go here 1, 2 will go here 2. That will be 0.5 times 2. That will give me the value of 1. So we can see that the area under the curve in this case is equals to 1. So I can conclude that it's a PDF. Good. So this is very great. I love that you guys have gotten the right understanding on this. So now it's time for you to solve questions. I don't expect at this point that any of you are still lacking in the things we have been talking about. All right. So can I get feedbacks from you guys? How do you feel now about continuous random variable? Just be very honest. At this point, we have done about 70% of the work on continuous random variable. Guys, is it clear? Are you guys seeing it clearly? So if you are really following us and if you're really following us, I trust me, you're already almost very good. Everything around PDS, you're already good. The only thing left now is for us to solve questions to consolidate your knowledge. Okay, you guys are talking about its below. I don't know, is it the focus of the camera? But can you hear me, please? So I wanted to check if for this given range, this check if this is a probability density function for this given range. All right. Oh yeah, let's move very fast. Tell me if this is uh tell me if this is a probability density function. Tell me if this is a probability density function. So you guys are doing really great. I love your responses. There's a particular question I want to share with you guys very soon. Very, very important. And after we're done, we'll talk about expectation and variance and probably solve just one question on that, and we're good. So you guys are saying it's a PDF. Now, let me quickly warn you guys. Can you tell me the reason why it's a PDF? Let me first of all ask that, so I'll be able to know if you guys are really doing the right thing. Why is this a PDF? So I will see who is going to give me the correct answer. I'm almost 70% sure many people will not get it perfectly. Why is it a PDF? So why do you call this a PDF? Why is this a PDF? Any answer? Let me get answers, please. Somebody, okay. Did I not say that I'm 70% sure? Nobody has gotten the right answer here. The first thing you have to say is that all the functions, I knew you guys are not going to get, they are all going to be greater than or equals to 0. That's the first rule. There are 2 rules. You are just saying if the integral is 1. Yeah, that's true that the integral is 1. But don't forget, these are the 2 conditions, not just one of them. That's what I wanted to point out. All right, we can move on from this question then. That was very vital. Now, we had this question before. So I want you to solve it. I remember with the first question we solved under this topic, we had a function. We were able to find the k value as 1/24. And I gave you 2 probabilities to solve. I already explained one. I explained one already. Of course, don't forget this thing was more like this, and then this was for your x value was between 1 to 4, and this one otherwise. All right. So the question is for you to solve the second probability that said probability of x being between following this range. So guys, can you solve this second probability? We solved the first one already. The first question was find probability of x being equals to 3. And I told you already that that answer is 0. So guys, what's the answer for this one? What's the answer for the probability being between between 2 and 3. So I really hope we can have the same answer. After this question, I'll be giving you a question and I'll be waiting to see who gets the answer. Do we have an answer yet? What's the probability of x being under the range that you have right in front of us? Oh, wow. People are screaming for me to solve it. Okay. All right. I'm going to solve it then. So now, I was assuming that you guys have already picked this up already. But no problem. Let me solve this. I told you guys already that when they tell you to find the probability of something like this, if you had a curve, for instance, let's say you had a curve. If this was represented on a curve, the curve would have been x would have been 1 to 4 because the curve would have been represented. This is the bandwidth. All right. Now, if they ask you to find, this is 2 and 3. If they ask you to find this probability, I told you that this would mean you are supposed to find the area under this curve this way. Now, but you can't do this because this is not very possible. So what you have to do here is to make use of integration. And all you have to do is to integrate the function 1 over 24, which is 1 over 24x squared plus 1. But you'll be using the limit that was given, which is 2 to 3. Now, I told you guys already that the use of the word not equals to or equals to here is not really consequential because 2 and 3, this is going to be the same, the limit you'll be using. Now, the other question I wanted to ask you guys was that you should go and solve this. This is the other question you guys will tell me the answer of. But let me solve this one first. Now, you want to find this one, all you have to do is integrate the function with respect to this limit. That's all. So let's see how we do that. So we're integrating 1 over 24x squared plus 1. I'm sure you know how to do that. 1 over 24 x squared. When we integrate x squared, what are we going to get? We're going to be getting x cubed over 3. When we integrate 1, we're going to be getting x raised to power 1 over 1, which is still x. All right. Now, what you have to do is to now put this limit 2 and 3. So 2 and 3. So this is what you have to solve. Well, the answer to this integral, of course, with respect to dx, let me write dx there, just for good mathematical expression. So that's what we have done here. We've integrated this. All right, this is the answer. So to solve this now, you will want to put your upper limit into this. That will be 1 over 24. That will be 3 cubed over 3 plus 3. All right, that's for the upper limit. Minus, then you put your lower limit 1 over 24. Then that will be 2 cubed over 3 plus 2. So this is what you have to solve. All right. So if you're going to get the right answer, you must solve this correctly. Now, looking at what we have here, you can see clearly that 3 cubed will be obviously 27. I don't want to, let me just write 9. Okay, you understand what I'm doing now. 1 over 24, 3 times 3 times 3, I will just write 9 plus 3. All right, because 3 times 3 times 3, 3 times 3 times 3 over 3. 1 3 cancels, we left with 9. That's how I'll just write 9 plus 3. All right, now this is this side minus 2 cubed. That will be 1 over 24 8 over 3 plus 2. All right. This is very essential that you are very accurate. Looking at what we have here, 9, 10, 11, 12. This is 12 over 24 minus 8 over 3 plus 2 should give you what? What is 8 over 3 plus 2? We should have 3, 8 plus 6. That's 14 over 3. So you have 14, 1 over 24. That'll be 14, 1 over 24, 14 over 3. All right? So if you go on to solve this, you can press this out. Of course, these two will go here 7, 2 will go here 12. That's 7 over 36. So that's 12 over 24 minus 7 over 36. If you find the LCM of this is 36. Is the LCM 36? Let me break this down to 1 over 12. So the LCM will be 36, all right? And that will be 12 going 36, that will be 3. Are you sure I've not made a mistake somewhere? That will be 3 minus 7. No, something is wrong somewhere. Where is my issue? Where's the can anybody spot the issue somewhere? I believe a mistake has been made somewhere. So your answer is supposed to be 11 over 36. So we have, it's correct till this point. So can you, okay, 1 over 2, thank you, exactly. That's very obvious. So not 1 over 12, 1 over 2. So this is going to be 2 going in 36. That will be 18. That will be 18 minus 7. Good. So that will be 11 over 36. Good. All right. So that's the answer to that question. All you needed to do in summary was to integrate the function with respect to the limit. Now, guys, what's the answer to this question? What's the answer to this one? This one. What's the answer? What's the answer to that second question? What's the answer to this question? Probability of 2 being between. What's the answer? I want to get solid responses. Exactly. That's exactly what I want to say. So the answer is actually still going to be 11 over 36. So good of you guys recognizing that. So that was what I wanted to bring out so that you guys will be. Now, this next question, only a genius will be able to get it. So if you get this question, you're a genius. Once you get this question, you are officially a genius. If they don't call you a genius, make sure you call yourself a genius. So you have to calculate the probability of x being between 2 and 4. So getting this question, we're going to officially name you a genius. So you'll be permitted to add genius to the front of your name as a prefix. So let me give you just 2 minutes to answer the question. Just 2 minutes. You don't need more than that. Is somebody writing 11 over 36? Did you say something about it being blurry? Is it better now? Can you see now? Can you see it now? Is it better? Can you see it? So we have the function, we have 1 over 6x. The range is x being between 0 and 3. We have 2 minus 1 over 2x. This range being between 3 and 4. And we have 0 for otherwise. Can you see it? Can you see it right now? Somebody said the answer is 2 over 3. By the way, nobody should use ChatGPT because I know many of you are the biggest client of ChatGPT. Somebody said 1 over 6. Okay. Different answers. Somebody said 1 over 4. Okay, we have gotten 3 different answers. Okay, let's give 45 seconds more. Okay, 20 more seconds. Okay, somebody said 1. Okay, it looks like maybe we're silent in this question. All right, let's solve together. Somebody said 1 over 4. Let's solve together. Looks like we don't have so many even answers. That means you guys found it difficult as expected. So this brings us to a very important aspect where one of the confusing things here is that you have this function, of course, and 0 otherwise. This function was for this range, and this function was for this range. Now, you guys would have enjoyed the question if the question said probability of it being between 2, maybe if they said 0 and 3. I'm sure many of you will have just gone on to use this first function 0 and 3, and you say we are out of here. I've gotten my answer. Now, if they told you to use 3 and 4, probability of x being between 3 and 4, you would have done the same thing, use this function. But now the issue is that you're told to find for 2 to 4. Now, 2 is within this place, 2 and 3 is within this range, and 3 and 4 is within this. So how then do you solve this? How then do you solve this? And that's why I was not surprised that many of you could not give the correct answer. Now, this is all you have to do. You have to split it into parts. Somebody is getting probability as minus 67 over 100. Really? Minus as an answer for probability? Now, what you need to do is to split this into parts. So, your probability is, well, you're told to find probability between 2 and 4. What you have to do is to find for 2 to 3. And also you go on to now find for 3 to 4. Anyhow you want to write this. If you want to write anyhow, it doesn't really, all this equals doesn't matter. So this is what you have to do. Now, for 2 to 3, this is your function of interest, because you can see that the function of interest that houses the range of 2 and 3, this function of interest was 1 over 6x, whereas the function of interest that houses the 3 to 4 was the 2 minus 1 over 2x. So what you have to do now is, of course, you go and find the probability of 2 to 3 with that of 3 to 4. So you'll be having the integration of this function 1 over 6x of 2 to 3. You will solve this with respect to dx, and then you'll be adding your answer with the integral of this function 2 minus 1 over 2x with this range 3 to 4. So that's what you have to do. All right. Now, I don't think anybody should have an issue in integrating this. If you have 1 over 6x, if you are going to integrate this, you'll be having 1 over 6x squared over 2. Of course, you are putting your limit 3 and 2. Then if you integrate this other one, integrating 2, you'll be having 2, of course, x raised to the power 1 over 1, which is still be 2x. If you're integrating the second one, you'll be having 1 over 2x squared over 2. And your limit there is 4, 3. So this is what you have to solve, all right? So this will be putting your x as 3. You're having 3 squared, that will be 9 over 12 minus, of course, I'm solving this and you know how to solve this. I'll put for my 3 into this expression. Putting 3 as x, that'll be 3 squared over 12. That's what I have here. 9 over 12 minus, putting 2 now, that'll be 4 over 12. So this is the first integration, plus the second one. You put in your value of this 4 as your x, you'll be having 2 times 4, that will be 8, minus still 4. 4 squared, that's 16 over 4. 16 over 4 is what? 4. That will be 8 minus 4. That's for when x was 4. All right, minus, you put for when x was 3. When x was 3, you'll be having, that will be 9. Sorry, 3 times 2, 6, not 9. 6 minus 3 squared, that's 9 over 4. 3 squared, 9 over 4. Does that make sense? Okay, so this is what you have to solve. And this is 9 minus 4. What is 9 minus 4? That will be 5 over 12. That will be 5 over 12. Okay, it looks like we are out of the range here. Five over 12. That's for this first function, plus this will be 4 minus, all in all, if you solve this whole thing, you should get 1 over 4. Right? And if you solve these two things, you should get 2 over 3. That's your answer. So just a quick comeback to all this. This is all that went on here. You were given a question. You had a function. This, don't forget, this is a piecewise function. For the range between 0 and 3, you were told this was the function attached to that. For the range between 3 and 4, this was the function attached to that. For every other range, the function was 0. All right. We're then told to find the probability of x being between 2 and 4. Now, this is the issue. There is no range for 2 and 4 in just one place. All right? So, there is no range for 2 and there's no range for 2 and 4. So what we have to do is to split this probability. So we'll be having, of course, this first range can cover 2 to 3. This other range can cover 3 to 4. So we'll be making use of this function with the range of 2 to 3. And we'll be making use of this function with the range of 3 to 4. So you just have to follow the same process. If you are going to find the probability of this with this function, what you have needed to do would have been to integrate the function. You can see the function we're integrating. The function is there with this range. Integrate that function with the limit 2 to 3, all right? And you'll be adding that with the other one where you are integrating the other function with the range 3 to 4. That's all we went on to do. Carefully and accurately, we got our answer to be 2 over 3. So that's how you deal with questions like this. All right. So if you really want to, this is how you solve questions under continuous random variable. So before we get into expectation, which will be the last aspect for this night, I really want to give you a question to solve, and let me see how you're going to be able to cope with this. Now, the question said, a continuous random variable had a PDF, of course, a probability density function, a continuous random variable had a PDF, and the PDF is given as f of x equals to kx squared. All right. And the range, a continuous random variable has a PDF where the f of x is given as kx squared. All right. And we have the range of value for x to be between 0 and 6. All right, does this make sense? Now, the first question is for you to find the value of k. All right, can you attempt that quickly? What's the value for k? And the second question is for you to find the probability of x being between 2 and 4. So can you guys give me an answer to that? I'll be giving you, we would not be able to do so much around the variance and expectation. I will just give you a question to attempt, and then we'll be picking up from there in our next class. But I want you guys to give me the answer to this question quickly. Can you guys solve this? A continuous random variable had a PDF where f of x is equals to kx squared, and the value for your x was between 0 and 6. So you have to find the value of k, and you have to find the probability of x being between 2 and 4. So how do you find the value of k? Do we have anybody with an answer? Okay. Okay, people said it looks, who is talking about it being blurry? Somebody said the answer of K is 1 over 72. Okay, it looks like many people are getting 1 over 72. Okay, all right. That's actually very correct. The answer for K is 1 over, so K is 1 over 72. All right. All you needed to do to find K was for you to go on to use the prerequisite for PDFs, which is that your integration of your function must be equals to 1. Now, in this case, now your function is kx squared. That means the integral of kx squared with the limit of 0 and 6 must be equals to 1. You go on to integrate this, of course, you would notice that this will be giving you kx cubed over 3, now with the limit of 6 and 0. That will be 6k 6 raised to the power 3 over 3 minus 0, obviously. Because 0 cubed over 3, all this will be 0. 6 raised to the power 3 will give you what? 216. That will be 216 over 3. 216k over 3. Don't forget, equals to 1. That means 216k equals to 1. Sorry, equals to 3. And your k will be equals to 3 over 216, which will be 1 over 72. All right, I believe everybody could follow that. Now, the next question said you should find the probability of x being. So what's the value for x being between 2 and 4? It's that simple. You can see how simple these questions are. All you needed to have known was the prerequisite, which was that the integral value, if it's a continuous random variable, if it's a PDF, the integral value of the function with its limit must be equals to 1. All right, very simple and straightforward. So what's the value for p being between 2 and 4? Of course, what you have to do here is go on to integrate the function. Now you don't have to write kx squared, you have to write 1 over 72 x squared. So you have to integrate this with respect to this bandwidth. That will be the limit being 2 and 4. So whatever answer you get here will be the answer. You go on to do this, obviously this will be, you will be having x cubed over 1 over 72 x cubed over 3 with 4 and 2. You put your 4 here, you'll be having 4 cubed over 72 times 3 minus 2 cubed over 72 times 3. If you solve this, you should get an answer of 56 over 216. And that should be 0.26. All right? That's simple, is it not? Guys, how do you feel about continuous random variable? Too simple, am I right? This is everything, by the way, just so you understand. If you have understood what we have been doing so far, you are really good to go. So now I'm going to just give you a clue on expectation and variances, and I'm going to set you guys to go and practice a particular question. All right, so I'm just going to give you the summary of what to do, and then you're going to solve yours. I'm going to give you a question, and you're going to go on to solve it. So the topic we are dealing with now is the mean and variance of continuous random variable. Now, just like we did on that discrete random variable, you have to be able to answer questions around mean and variances of continuous random variable. Don't forget, can anybody tell me another word for the word mean? I said it in probably yesterday's class. Mean. What is another word for the word mean? What's another word for the word mean? Somebody said average. Average is not the word I expect you to say. Expectation is what I expected you to say. And that will be written as E of X. All right. Now, when we're dealing with discrete random variable, I'm sure you can recollect how we solved for the expectation. Now, it's the same thing, only with a different flavor. And this is why. Look at it. Expectation under continuous random variable. Just to recollect, when you were doing discrete, you had summation. Under continuous, you will have integration. The same thing. X, f of x. That's all. Of course, you will be differentiating with respect to x. And I'm sure, of course, this is a general expression, so I'll be putting minus infinity to infinity. And I'm sure everybody understands why I'm putting minus infinity to infinity. The meaning of this is just saying whatever your limit was. So tomorrow you may be given a limit of 1 to 4. In another case, you may be given a limit of 0 to 3, depending on whatever your limit was. That means in this case now your x is ranging between infinity and minus infinity. All right. Now, this is how you find expectations. Under discrete, you find expectation by doing it. The difference is just that you'll be having summation under discrete. Under continuous, you'll be dealing with integration. So the meaning of this is that if you had let's say you had a function, I'll give you an example. Let me just say you had a function x cubed over 4. Let's say this was your function. If you are told to find the expectation of this function, and let's say your x was between 1 to 4. Let's say x was between 1 to 4. If you wanted to find the expectation of this function, you will just need to go on to say the expectation of x will be equals to, of course, the integral of x. Now, you'll be adding an x with the function times x cubed over 4. You'll be integrating this with respect to x, obviously, and you'll be setting your limit to 1, 4. That's the way you solve for expectation. All right. So the difference would be that you'll be adding an x when you're dealing with expectation. So you will not just be integrating the function alone. You'll be integrating with, you will have to multiply the function with x, then create this all together. That's the way you find expectation. And you set the limit of whatever you were given for your integration. All right. So now that's that about that. I'll give you a question you guys will solve yourself. Now, that's that about expectation. What about variance? Again, variance of x. How do you find variance of x under continuous random variable? It's the same thing also as you solved yesterday for discrete. The expectation of x squared minus expectation of x all square. All right. So this means obviously that for you to be able to find the variance, you would have needed to have found the variance, the expectation of whatever continuous random variable you are dealing with. And that will mean because you'll be needing it right here. Whatever your expectation was is what you'll be putting here. Then you'll be squaring whatever the answer was, just like we did on that discrete. All right. Now, the question then goes, how do you find this other side, expectation of x squared? I'm sure you guys already can presume what it will be, just the same thing. In this case now, when you're having x squared, what you'll be doing is that you're integrating not x now, x squared multiplied by the function with respect to the x, depending on whatever limit you are given, obviously. So this is where it gets very interesting. If you are told to find the variance, of course, just imagine we wanted to test you. Of course, it'd be very great for me to just tell you to find the variance, because you cannot get the variance without finding the expectation. So the variance tests your ability to get the expectation and also the e of x squared. So and how do you find the e of x squared? You need to go on to you will be multiplying the square of x with your function, just to give you an hang of that. Let's say your function was x squared over 2. Let's say this was your function now. If you wanted to find e of x squared, what you just needed to have done is to integrate. Let's say your x was between 0 and 3. All right. So I needed to integrate. Now, this is for x squared. So you will have to say x squared times now x squared over 2. This is the function. All right. With respect to dx. Now your limit will be between 0 and 3. So if I wanted to integrate this now, we have to integrate this together. Of course, if you multiply this together, this will give you x raised to the power 4 over 2. All right. So it is this function, when I've multiplied it with that x squared, that I'll be integrating. All right. That's how you find e of x squared. For that of expectation, is only x will be multiplied with the function. But if it's e of x squared, you'll be multiplying x squared. And don't forget, this is not the end. After you get this answer, e of x squared, you will need to go and subtract the square of the expectation from it before you can say that's your variance. I'm sure you guys are understanding what's going on here. It's the same thing, just that in this case, you'll be dealing with integration. Now, this is the question I have for you guys, and I'm sure you will not miss it. You have to solve carefully. You have to solve very carefully. And this is actually the end of continuous random variable. All right. This was really a productive weekend. Really, really productive. You guys really understood this topic, I can see. And that is really great. So I'll be very happy to give you a test. Of course, prepare for a quiz test. And I would be expecting the percentile to be at least the 95th percentile should be about 100%. 100 over 100. Now, this is the question I have for you. A continuous random variable has a probability density function given as this. Look at the function. F of x is equals to, now this is the function 1 over 3x plus 1 over 6. Of course, this is the range for that function. 0 less than x less than 2. That's the range for that. And 0 otherwise. So this is the question. You have to find the mean. You have to find the variance. And you have to find the standard deviation. I want this question to be done in your notes, and I want to see it on Tuesday. This question should be done in your notes, and I want to see it on Tuesday. Does that make sense? So please prepare for a test. Continuous random variable, discrete random variable, everything random variable. Uh, we are we have come to the close of random variables. Really, really great. You guys, you exceeded expectation. You were able to cope with this topic far beyond what I would have expected, and it's really nice. Please keep it up. You have done really great now. The introduction to random variables has been really great. Discrete random variable, continuous random variable. You know what discrete data are. You know what continuous data are. You know, you can. I believe you should be able to define what random variable is now. All right. Can anybody quickly just give me a hang of what random variable? Can you just say it in the comment section? What do you understand random variables are as? I want to see if you guys can say this in a very eloquent way. Uh, so you should be able to say all these things very perfectly. What is a random variable? Of course, it's the numerical uh, value assigned to the outcome of a random experiment. That's good. Thank you very much. Unnamed. That's really great. And you should be able to differentiate. By the way, I think did I give you an assignment to tell me five different, did I give you an assignment? Okay, let me give you an assignment quickly on random variables. Please give me five different examples of discrete data and five different examples of continuous data. Please do that, write that in your notes. Five examples of discrete data, five examples of continuous data, so that you guys can be very sound in that. So please, this is also an assignment, mean and variance of a continuous random variable. Please, I want to see this in your notes. Very, very important. Prepare for a test. Guys, it's been a very tremendous, terrific moment. The next topic now is for us to delve into probability distribution function, where we are going to be talking about Bernoulli distribution. We're going to be talking about binomial distribution. We're going to be talking about geometric distribution. We're going to be talking about Poisson distribution. Those four distributions I mentioned are all discrete probability distribution. And we're also going to be talking about normal distribution. Normal distribution is an example of continuous random variables, continuous distribution, continuous probability distribution. So we have discrete, we have continuous. We're going to be delving into that in our next classes. So that's the next phase of what we have to do. And if you really understood this one very well, I don't believe you would have any issue with the topic coming ahead of you. So guys, thank you very much. This is really great. Thank you very much. Thank you very much. Make sure you do all the work you have in front of you. And yeah, enjoy yourself. Take care of yourself. Good night, everyone. Good night. All right. Thank you very much, Johnson. Thank you, David. Thank you. Thank you, Covenant. Thank you, David. Thank you. Bye bye, Innocent. Thank you. Thank you. Thank you, Opeyemi. Thank you. Thank you. Emmanuel, thank you. Praise. Okay. Precious. Edith. Modric. I. Abiola. Samuel. All right. Ayeni, David. Oh, love you too. Whoever that is. Okay, Abiola. Love you too. Be great, be good. Make sure you succeed. Make sure you do well. Oni, thank you very much. Reggio Odonayo, I'm not feeling cold at all. Thank you. Benjamin, good night. Adebayo, thank you. Oh, Elon Musk is right in the building. Oh, really? That's nice. Okay. All right, guys. Bisayo, good night to you. All right, good night, everyone. do enjoy your night, enjoy yourself, and make sure you do well. Bye bye.